Hello from sunny Tromsø in northern Norway. My name's Emily Venables. I'm a technician at the University of Tromsø. I work within the Arctic Marine Biology department there, but my role is as an engineer rather than a researcher, and I look after all the marine robotics that we are implementing within the department. As a university, a massive benefit to the students that are studying marine biology is to be able to get a first eye view of what they're studying underwater. So without becoming a scuba diver, Blueyes make them able to see the organisms that they're studying and get a really good view of what they're looking at underwater. In the past, they've only been able to look at videos, what's been trawled up, samples that they can count. But now they can come down to the beach, they can come on a cruise, and they can have a live display of what they're sampling underneath them and how those communities interact. UIT recently has taken delivery of a number of Blueye ROVs, and we're trying to integrate them into the marine biology courses, into research projects, and my job is to enable people to use them. So the first thing I've done is set up a checklist, give people some basic tips and training, not really much more than is in the operations manual, but it's good to talk these things through with people, make sure they remember things like putting the connector caps on once they've charged the battery. But the great thing about Blueyes is they really are quite foolproof. They're quite simple to use, they're very robust. So really we're just trying to encourage people to use them, not be scared. On the marine biology course, the students have been able so far to use the ROVs to extend their studies of the intertidal zone. So every year there is a trip to the intertidal zone and they look at the species that are living on the shoreline, and having the ROV enables them to continue their transects of what they can see on the beach further underwater. And it also means that they can see intertidal species, but when the tide's in. So how they behave differently when they're flooded as opposed to when they're on the beach. The ROVs were super valuable for a student cruise when we were working with UNIS, the university in Svalbard, where there were postgraduate students on a benthic ecology course. And we were able to take ROVs on that cruise with them, and they were using the video as part of their analysis. They could analyse the images from the ROVs to see what species were living in the various zones in the different fjords at different depths. So that was really useful for them. Blueyes are great in that you can so quickly have eyes underwater. It's very simple to set up and you can quickly record video, get images of things that normally you'd have to have a lot of faff and put dive gear on, or send a camera down that maybe wasn't real time. Blueyes are just instant heads-up display of what you're looking at underwater, so really helpful. The biggest difference between Blueye and other underwater technology that I've used myself is primarily the app nature of it. The app makes things very simple, it makes the connections quite straightforward. Most of the instrumentation I've used in the past has been quite heavy, more programming language to speak to the instruments, usually through a laptop, whereas the setup on your phone with an app makes it really, really easy. So one of the research projects that we're using the Blueyes for at the moment is going to be a slow process, but we have a very long time series of photo stations, and those photos have always been taken by divers, and we're working on whether at some point the ROV technology and the image quality from ROVs can ultimately replace diver footage, because they are a lot cheaper than divers. Thanks for listening to me, and good luck with your Blueyes.